Welcome to another installment of You Can Do Math. In this one we'll be covering decimals and percent. So before we can start talking about decimals, we have to review, or rather explain a concept known as place value. In the numbering system we use, perhaps I'll pick an example. Suppose I have the number 33. Now, even though I have the same symbol in both places, this place is 10 times this place. So this is the tens, and this is the ones. So this is telling us we have 3 tens and 3 ones. And if I had, for example, 333, this is the hundreds place, so hundreds, tens, and ones. So this is telling us we have 3 times 100, and then 3 times 10, and 3 times 1, all added together, which adds up to 333. And of course we can extend further to the left with thousands, thousands, 10,000s, 100,000s, so on. But the main point is, as you go to the left, each number is 10 times more than the number to the right of it. So to pick a similar example, if I have, instead of 3.3, here's ones, and this is tenths. But one position, this is the tenths position. So this is telling us we have 3 times 1 and 3 times 1/10 is the total number. And just as we can have ones, tens, hundreds, and thousands, we can have tenths, hundreds, and thousands. So for example, I could have, say, 3.123. So this is telling us we have 3 times 1, and then 1 times 1/10, 2 times 100th, and 3 times 1,000th. And that will come out to 3.123. So another way of writing 1/10 as a decimal would be 0.1. 100th, it would be 0.01, and 1,000th would be 0.001. And you can add and subtract decimals just like regular numbers. You can add, subtract, multiply, divide. You just have to be a little careful with the decimal point. So if I had, for example, 2.45 plus 1.06, treat it just like a regular addition problem. 5 and 6 is 11. Carry the 1. 1 and 4 and 0 is 5. Bring out our decimal point. 1 and 2 is 3. Simple enough. If I have a subtraction problem, so I have, say, 7.67 and 4.92. 7 minus 2 is 5. 6 minus 9, we need to borrow 1. So we'd have 16 minus 9 is 7. 6 minus 4 is 2. You just, as long as you remember where the decimal point is, you're good to go. It's the same rules as what we had for whole numbers. And the multiplication is a little trickier, but it's not too bad. So if I have, say, 3.74 times 0.51, okay, so the key to this is to ignore the decimal point while you're working the problem, but what you do need to do is count the number of digits that are to the right of the decimal. So up here we have 2 digits to the left of the decimal, so 2, and then we have 2 more digits to the left of the decimal, like that. So when we work this problem, we're going to work it as though we're multiplying 51 times 374, and then when we're done, we're going to move the decimal point backwards to where it was before. So let's work out 374 times 51, since that's easy enough. Okay, so I like to, there's a traditional way of multiplying which I think is a little confusing, so I'm just going to do it in chart form. So first we'd have 1 times 4, that would be 4. Then we would have 1 times 70, which is 70. Then we'd have 1 times 300, which is easy enough. It's 300. Now we have 50 times 4. Remember this, although this is a 5, it's in the tens place, so it's 50. So 50 times 4 is 200. 50 times 70 is going to be 3,500. So the trick to this one is, first we say 5 times 7 is 35, and then we have 1 0 and 2 zeros, so we just put on 2 more zeros. It's pretty easy. And then last we have 50 times 300. And in a likewise manner, or sorry, 50 times 300. So 5 times 3 is 15. We have 1, 2, 3 zeros, 1, 2, 3. So if we add up all that, let's see, we'd have, this would be, up to here we'd have 374. Put on another 200, it would be 574. Here we'd have 3,500 and 15,000 would be 18,500 and 574. So this would lead to, what is it, 74, carry the 1, so it'd be 19,074. I'm running out of room there. So I'll just write it down here. 19,074. Okay, but remember, we moved our decimal points 4 places. So that means when we get to the very end, we have to move it back 4 places. So, if we take the number 1974, or 19,074 decimal points here, we got to move it to the left 3 places, or 4 places, so 1, 2, 3, 4. So now our answer is 1.9074. And that's how we do multiplication with decimals. First you change them both into whole numbers while counting the number of times you move the decimal point. Then when you get to the end, you move your decimal point back the opposite direction. And the multiplication by parts, as I did here, it takes up a little more room, but I think it's a little easier this way, and you're less likely to mess up. I always had trouble with the traditional method, so. Division, it's a similar idea. So if I had, for example, 5 dividing into, say, 0.85, So I would first move the decimal point on both numbers so that I have a whole number. So 2 here, and then make this 500. So I would have 500 being divided into 85. So this 0.85 divide 5 is the same as 85 divide 500. Okay, so 500 won't go into 8, it won't go into 85, it does go into 850, so we put our decimal point there, so it goes into 850 once, this brings us 350, bring down a 0, so 500 goes into 3500 7 times, so our answer is 0.7. And that's pretty much the gist of it there. In division, you don't need to move your decimal point around because it's equivalent. So the dividing 0.85 by 5 is the same as dividing 85 by 500. So there's no need to, move the decimal point backwards in your final answer as we did when we were doing multiplication. Let's see. There's something that doesn't seem quite right about that answer. 0.85 divide 5 should be a lot less than 0.7. Where is my mistake? Oh, that's not 0.7, it's 0.1. My mistake. It would be 0.17. I jumped the gun there. Yes, 500 goes into 850 once, and then goes into 3500 7 times. So our answer is going to be 0.17. Everybody makes mistakes. The important thing is to catch them. And I suppose the last thing I'll touch on with decimals is converting decimals into fractions is pretty straightforward. So I'll just do a little abbreviation for going between decimals and fractions. So the trick is, so if you have, say, 0.8, okay, this is 8/10. So what you do is you look at the number of digits to the right of the decimal you have. So if you have 1 digit, that would just be 10. This is the tenths, and then we write the 8 on top. If I had, say, 0.83, that would be the same as 83 over 100. So you write the numbers you have, and then you count the number of places, and then you write 1, and then the number of zeros on the bottom will equal the number of digits you have on top. So if you have 2 digits on top, you have 2 zeros on the bottom, 1 digit on top, 1 zero on the bottom. If I have, say, 0.837, that's going to be 837 over 1,000. So converting between fractions and decimals, well, converting a decimal to a fraction is pretty easy. You might need to reduce it. Whoops, there should be another 0 there. Yeah, 1, 2, 3 digits, 1, 2, 3 zeros. Converting fractions into decimals is just a matter of doing the division. So if I have the very common fraction of 1/2, that's the same as saying 1 divided by 2. So 2 going into 1. 2 can't go into 1. We write a 0, put our decimal point. 2 goes into 10 5 times, right? 5 times 2 is 10. So 1/2 is the same as 0.5. Another common fraction, 1/4. 1 divide 4. Same idea, 4 can't go into 1. Write a 0, put our decimal point. Put a 0 here. 4 goes, the closest we can get is 2. 2 times 4 is 8. 2, bring down a 0. And then 4 can go into 25 times. So that means 1/4 is the same as 0.25. So it's pretty easy to convert between decimals and fractions. It's just, to convert to a decimal, you just count you write the digits you have on top. On the bottom, you write 1, and then followed by a number of zeros that's the same as the number of digits on top. And then to convert a fraction to a decimal, you just do the long division. Pretty straightforward. And the last thing I want to talk about in this lesson is percent. So for example, 50% is the same as half, which is the same as 0.5, which is the same as 50 out of 100. Or perhaps I should say, to convert a percent to a fraction, first we say, if I have, say, 73%, this is the same as 73 out of 100. Percent literally means per 100. So if you have 73%, that's 73 out of 100. And as a decimal, that would of course be 0.37. So converting between fractions, decimals, and percent is pretty straightforward. Nothing too hard going on there. And I guess the last thing I'm going to talk about is percent increase and decrease. So I suppose the most common everyday example of this is 15% tip being added to a bill. So suppose the bill for the meal was $24, and you want to roughly $24, and you want to calculate the tip. And if you don't have a calculator or a cell phone with a calculator, you don't know how to use it, how would you do this? Well, what you would do, perhaps I shouldn't use parentheses to indicate multiplication yet. Haven't talked about those. What we do is we take that 15%, we turn it into a decimal, which is 15 out of 100. So the total bill is going to be the bill itself plus 15%. So it's going to be $24 plus 15% of 24. So it would be 0.15 times 24. Guess I can erase the dollar sign. Okay. So 15%, 0.15 times 24. Okay, so we're going to move our decimal point 2 spaces to the right. Now, make sure we remember to move it back when we're done. And now we're just going to treat it just like 15 times 24. 5 times 4 is 20. 5 times 20 is 100. Then we'd have 10 times 4 is 40. And 10 times 20 is 200. We add that all up. So 360. But of course we have to remember to move our decimal point back the other way. So we move it back 2 spaces. So our answer is going to be $3.60 is the amount of the tip. And so the total amount will be $24 plus $3.60, which would be $27.60. See, not too bad. So this is an example of a percent increase. It's 15% more than this 24 number. To calculate the percent decrease, so for example, if a store is having a sale, and say the sale is 25% off everything, so suppose you're the storekeeper and you want to take 25% off the cost of everything. So suppose you have an item that's, let's say it's $10. And if it's $10, you want to take it to 25% less, what would that new price be? So what we do is first we take 25% of 10. So 10 times times 25% is the same as 10 times 0.25, which is 2.5. Okay. So this is the percent we're taking off is 2.5 or 250. So we take 10 minus 2.5, right? Because we're taking it off, it's going to be less. So 10 minus 2.5 is 7.5. So that means something that was originally $10 is now going to be $7.50. So in each of these examples, what you do is first you find the percent of the original amount, and then you either add it on if it's going up, or you subtract it if it's going down. And I suppose I'll end the lesson there, and for the next lesson, I'll be finishing off the last few topics for arithmetic, and then we'll be moving on to, I suppose, geometry.